So the truth, Oumuamua, or Oumuamua, this big comet-like, this big cigar, this UFO attack from the Virga, or Lyra, the Lyranians. The Lyranians have attacked us, right? So Oumuamua is red. The Andromeda Galaxy is in the Virgo constellation. Oumuamua is red, tumbling, but it's silent. There's been no radio waves. So there's Mrs. Bannister, or Miss Bannister, said it's a planetesimal with a well-baked crust that looks a lot like the tiniest worlds in the outer regions of our solar system. A planetesimal, the well-baked crust. So a lot of these scientists are saying that this was formed during the beginning of the Big Bang, when it all formed. But couldn't it just been a rock just tumbling around for years? How do they know specifically? It was like, this is how old it is. It could just be space trash. It's probably an asteroid, not a comet, right? Just some space trash, some rock out in the middle of a galaxy, just tumbling between solar systems and galaxies and worlds for millennia or eternia. One fan theory said that the aliens just passed Earth up because they're like, some facts, one day Andromeda and the Milky Way are going to collide into each other. So Andromeda and the Milky Way, Andromeda is the closest galaxy to our Milky Way galaxy. And one day we're going to collide into each other. So you got that to look forward to. Newton's first law of motion is, in an inertial frame of reference, an object either remains at rest or it continues to move at a constant velocity unless acted upon by a force. In an inertial frame of reference, an object either remains at rest or it continues to move at a constant velocity unless acted upon by a force. Newton's first law of motion. Shape of Oumuamua's path as a hyperbola. Oumuamua's path as a hyperbola from Lyra to Pegasus. So it's coming from the Lyra constellation, and now it's headed towards Pegasus. 96% of the object had absorbed light, so it was mostly dark. The only thing we saw was a light reddish hue, but 96% of it was black, like asphalt. We saw the hue, which indicates that there's some carbon to it. September 9th is its perihelion, the perihelion. The perihelion is when it's closest to the sun. And I don't know why that's important. I would rather know the point of the hyperbola. But September 9th, it was really close to the sun, but it didn't burn up and it didn't evaporate. So it's not a comet, because if it was made of water, it would have evaporated. And I'm a socialist, Antifa, independent, green, progressive, revolutionary, who, you know, just wants good things for everybody, who wants to liberate everybody, a liberationist, freedom for everybody, justice and freedom for all. Perihelion was September 9th. That's when it was closest to the sun. That's what a perihelion is. And it was discovered after it passed Earth and was on its way out. So October 14th is when it came by Earth, which was about 60 times or 40 or 85 lunar distances. So take the distance between the moon and the Earth and then multiply that by 40 up to 85 lunar distances. It's close in terms of space, especially since no interstellar objects ever fall. Right? That's what they're saying. This is the first one ever. So no interstellar has ever fallen, but the first one nearly took us out, nearly wiped us out, just like how the dinosaurs went. So it passes by us October 14th. We see it October 19th, so the threat was already past us, right? And since it went ahead and slingshot across off the moon, the first law of thermodynamics, when energy passes as work, as heat, or with matter into or out from a system, the system's internal energy changes in accord with the law of conservation of energy. Equivalently, perpetual motion machines of the first kind, machines that produce work with no energy input, are impossible. That's the first law of thermodynamics. When energy passes as work, as heat, or with matter into or Oumuamua is, being thrown out, right? It comes into the solar system and then slingshots, and now it's just going super fast out of the solar system, and so that's what makes it interstellar. It's going to come in, and then it's going to, break the escape velocity. then it's going to leave the solar system. So the threat of it smacking into Earth, creating a big winter, smacking into Earth, and then knocking us out of the orbit, if it was going to destroy us all, we would already be dealing with its consequences by now instead of idle speculation. So I think we should speculate about it now so we can, if this was worse, we can at least have a contingency plan. I don't know if anybody has in case a comet or asteroid smacks into Earth, contingency plan, but it seems like you should have one. Good news is Trump's probably going to blow us all up with the new Bernoulli's principle is fluid dynamics. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. Again, Bernoulli's principle states, this is fluid dynamics. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy, or both. Alan Fitzsimmons commented that we have discovered that the surface of Oumuamua is similar to small solar system bodies that are covered in carbon-rich ices. This guy's still stuck on it being a comet, whose structure is modified by exposure to cosmic rays. So carbon-rich ices. We've also found a half-meter thick coating of organic-rich material that could have protected a water ice-rich comet-like interior from vaporizing when the object was heated by the sun, even though it's heated to over 300 degrees centigrade, which is very, very hot. So it's clearly not a comet, Alan Fitzsimmons, a fast-moving asteroid. But interesting, right? The organic-rich material is covering it, is something he admitted to, and it's carbon-rich, right? So there's carbon-rich. The A212, the second law of thermodynamics in a natural thermodynamic process, the sum of the entropies of the interacting thermodynamic systems increases. Equivalently, perpetual motion machines of the second kind, machines that spontaneously convert thermal energy into mechanical work, are impossible. So in a natural thermodynamic process, the sum of the entropies of the interacting thermodynamic system increases. NASA has prepared a nice visualization of the object's path. Based on the current trajectory, the visitor came from the constellation Lyra. Vega is in Lyra. That's the brightest star in Lyra. Vega is also the second brightest star of the northern hemisphere. So Vega, second brightest star of the northern hemisphere. Look outside. The second brightest star is Vega, after Arcturus. The fifth brightest star in all, surpassed only by Arcturus, Alpha Centauri, Canopus, and Sirius. Vega was the pole star in the year 12,000 BCE, will again be the pole star around 14,000 CE. This one appeared to be coming from the constellation Lyra. It approached our solar system from above, perpendicular to the plane that most planets orbit the sun. September 9th was its perihelion, less than a quarter mile long. Third law of motion, his third law is when one body exerts force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. So for every force, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. That's Newton's third law of motion. For their naming system first it was A21, 2017 U1. They changed it. First as a comet, then it was an asteroid. And they don't name it but the name, they name it with numbers. Scientists, it's almost like they don't want anybody to know what the fuck is going on. So they named the comet A2017U1, A for asteroid, and then they changed it to I2017UI, or U1, I for interstellar. So they changed A to 1I, the first interstellar, and then they named it, right, Oumuamua. And that's what everybody's going to know this thing is Oumuamua. Who the fuck is going to, trip over, oh, so hey, did you see that 1I 2017 UI? What did you think about the 1I 2017 UI thing that flew by? It's like I quit listening after one. The third law of thermodynamics, the entropy of a system approaches a constant value as the temperature approaches absolute zero. With the exception of non-crystalline solids, gases, the entropy of a system at absolute zero is typically close to zero and is equal to the natural logarithm of the product of the quantum ground states. Simple. That's the third law of thermodynamics. Number for pi, it's a very special number because it's the diameter of a perfect circle is equivalent to 3.1415926 by pi. So you just take the diameter, multiply it by pi, and then you'll get the circumference of a circle. And so the pi actually goes on forever. Pi is 3.14159265359. That's just for a couple of digits. But if you want to see, pi actually goes 3.141592653832795028841971693993751058209749445. The zeroth law of thermodynamics is if two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. If two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This law helps define the concept of temperature. The four laws of thermodynamics define fundamental physical quantities. Our total, we've had 5 interstellar probes, 5 probes that we sent to out of our solar system: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. As of 2015, the only probe that's actually reached interstellar space, Voyager 1. That's it, just Voyager 1. And we sent that back in the 70s. So we got Voyager 2, Pioneer 10, Pioneer 11, and New Horizons, which is still floating out there. Hopefully it's going to get to interstellar space. They're on interstellar trajectories. When Voyager 1 broke free from the solar system's repressive gravitational curvature of space-time is when the Voyager 1 passed the heliopause. The region beyond the heliopause is the interstellar medium. So get past the heliopause and you've broken free from the solar system. Laws of thermodynamics define fundamental physical quantities, temperature, energy, and entropy that characterize thermodynamic systems at thermal equilibrium. The laws describe how these quantities behave under various circumstances and forbid certain phenomena such as perpetual motion. Probes will be under the influence of the sun for a long time, but their velocities far exceed the sun's escape velocity, so they will eventually leave forever. The escape velocity is the velocity that which you need in order to escape the sun's gravitational curvature of space-time power. So the termination shock is the point in the heliosphere where the solar wind slows down to subsonic speed, and then the heliopause is the boundary where the sun's solar wind is stopped by the interstellar medium. The interstellar space is defined as that which lies beyond a magnetic region that extends about 122 AU, astronomical units, from the sun as detected by Voyager 1, and the equivalent region of influence surrounding other stars. Voyager 1 light year is equal to 5.88 trillion miles, or 9.5 trillion kilometers. 1 light year, 5.88 trillion miles, 9.5 trillion kilometers. Really, really, really far away. An astronomical unit is the distance between the Earth and the Sun, which is about 150 million kilometers, or 93 million miles. That's what an astronomical unit is. 150 million kilometers, 93 million miles. By Newton's three laws of motion, there are three physical laws that together laid the foundation for classical mechanics. They describe the relationship between a body and the forces acting upon it and its motion in response to those forces. More precisely, the first law defines the force qualitatively, the second law offers a quantitative measure of the force, and the third asserts that a single isolated force doesn't exist. Currently more than 150,000 AUs, 2 light years from the sun, can be considered lost to the interstellar medium. So what was that? Was that a missile sent by a hostile alien race wanting to attack us for some of the nuclear radiation bullshit we shot out into space 50 million years ago? It was a natural body. It was an alien object. It is a UFO since it's an undefined, whatever flying object, so we don't know what it is. It's a half-meter thick crust. So we know several things, right? We know that it's 96% dark. The slight reddish hue, cigar shaped. It's the size of London's Gherkin skyscraper. It's more effectively reflected reddish light than bluish light, a roundabout consequence of high energy particles flung off as shrapnel from these cosmic cataclysms such as supernova, and these high energy particles have been thrown onto Oumuamua. Over eons, this interstellar radiation can spark the formation of reddish, carbon-rich crust on the surfaces of comets and asteroids. The Gemini data says the surface of Oumuamua is bone dry and devoid of water ice. Thermal simulations of the carbon-rich layer suggest that if this schmutz were about 16 inches thick, Oumuamua, it could insulate an ice-rich interior. As usual, he was pretty much on the button, says Fitzsimmons, though unlike the alien ship Rama, Oumuamua appears to be natural in origin. These studies, among others, tamp down speculation that Oumuamua may be an extraterrestrial artifact, and there's only about 100 different atoms in the entire universe. Just 100 different atoms, only 100 tiny little pieces that make up everything else. So they said because it looks like there's some carbon, then perhaps there's other planet life, because it's just like our comets and asteroids. Oumuamua is just like us. Some people saying that it's slingshot by Jupiter. It's going to come back to the sun, accelerates when it goes faster into a gravitational well. In the near infrared, there are no signs of metallic surfaces on the object. Also, Breakthrough Listen Project, which looks for extraterrestrial radio signals, heard nothing but silence. So no radio waves, no metal on the surface. We've seen what reflected spectra of spacecraft look like, says Bannister. This is not it. So matter dictates how space is distorted around it, and then space dictates how matter can move. Space directs matter, matter shapes space. So that's relativity. Relativity is that time and movement is relative, but light is not. Light is the absolute. Light is constant, and it's the fastest thing in all the universe. Light is constant. Any planet within 10 light years of a supernova is going to be destroyed. So any planet within 10 light years. So, if there's a supernova around, measure it, make sure it's more than 10 light years around, or that's Earth. We're goners. There's several examples that Stephen Hawking gives for realism being bullshit. So a bunch of examples, right? So Ptolemy, he was able to use his stupid-ass system to get light, to figure out light, so even though his model was wrong. Another one, the holographic principle, says that we have 5 dimensions. So we have, what, a 4-dimensional world? We're just goldfish in a 4-dimensional world? And isn't this 3D? What about space-time? Isn't that 4, 5 dimensions? What if we live in a 5 or 6 or 7-dimension world? Then that means we would be a goldfish, only, with some facts. One day Andromeda and the Milky Way are going to collide into each other. So Andromeda and the Milky Way, Andromeda is the closest galaxy to our Milky Way galaxy. And one day we're going to collide into each other. So you got that to look forward to. In the third law of thermodynamics, the entropy of a system approaches a constant value as the temperature approaches absolute zero. With the exception of non-crystalline solids, gases, the entropy of a system at absolute zero is typically close to zero and is equal to the natural logarithm of the product of the quantum ground states. Simple. That's the third law of thermodynamics.